Trigonometry. What is it? Simply put, trigonometry relates to the angles and sides of triangles. Its main subject lies in geometry. Trigonometry primarily deals with right-angled triangles, where one of the angles is 90 degrees. The three main functions in trigonometry are sine, cosine, and tangent. The right-angled triangle is labeled as follows: hypotenuse, opposite, and adjacent, with hypotenuse being the longest. In these right-angled triangles, there are angles denoted by a symbol called a theta. For a right-angled triangle, the sine of an angle denoted as sine theta is the ratio of the length of the opposite side to the hypotenuse. The cosine of an angle, cos theta, is the ratio of the length of the adjacent side to the hypotenuse. The tangent of an angle, tan theta, is the ratio of the length of the opposite side to the adjacent side. Now I know that these might be hard to cram and remember, so there's a mnemonic to remember these: SAUKATOA. We will be using this mnemonic for the majority of this video, and it's easy to remember this. The first one, SOH, means sine, and the OH means opposite over hypotenuse. Similarly, CAH stands for cosine's ratio of adjacent over hypotenuse. And finally, TOA stands for tan's ratio of opposite over adjacent. One thing that confuses a lot of people is which side is adjacent and which is opposite. It's simple. An opposite side is the one across from a given angle, and an adjacent side is next to the given angle. For these functions, there are reciprocal functions: cosecant, secant, and cotangent. I will talk about them as we progress, but we'll focus on the primary three for this video. Let's dive into some problems to see these functions in action. Question number 1. You are given a right triangle where the adjacent and opposite sides have a value of 6 and 8. The hypotenuse is denoted by x. What is the sine, cosine, and tangent? First, we need to use the Pythagorean theorem to find the missing side. Hence, let's write down the formula: ae squared plus b squared equals to c squared. Now, let's input the values. 6 squared plus 8 squared equals c squared. Therefore, you get 36 plus 64 equals c squared. 36 plus 64 is 100. 100 equals c squared. Finding the square root of both gives us c equals 10. Hence, the missing side hypotenuse is 10. The triangle is 6, 8, 10, which is a special triangle. I will elaborate on special triangles more in my upcoming videos, but for now, you can just remember some like 3, 4, 5, and the one we have right here, 6, 8, and 10. Now, our goal is to find the sine, cosine, and tangent. Remember SAUKATOA? We will be using that to find it out. Firstly, in SOH, the sine of an angle is the ratio of the length of the opposite side over the hypotenuse, which is 6 over 10. Cosine, CAH, is the ratio of the length of the adjacent side to the hypotenuse, which is 8 over 10. Lastly, tangent, TOA, is the ratio of the length of the opposite side to the adjacent side, which is 6 over 8. Let's move on to more questions to test your skills. Question number 2. Calculate the length of the hypotenuse of a right triangle with sides of 9 centimeters and 12 centimeters. Then find the sine, cosine, and tangent. Firstly, we will find the missing side by using the Pythagorean theorem just like we did in the last question. So, let's write down the formula. Now, we will input the values. 9 squared plus 12 squared equals c squared. Squaring both will give us 81 plus 144 equals c squared. 144 plus 81 equals 225. Square root this equation, we have the missing side. C equals 15. The missing side is 15 centimeters. Notice that this is also a special triangle because if you multiply 3, 4, and 5 by 3, you get 9, 12, and 15. Hence, you can find quick answers if you know special triangles. Find the sine, cosine, and tangent. I am going to leave this question to you to solve. You can pause the video and give it a try. All right, these are the answers if you got them. Remember that we will now be going through some tougher questions, but they are easy to solve, keeping the basic trigonometric functions in mind. Question number 3. Below is a right-angled triangle. You must find the length of x, given the length of the hypotenuse, 7 centimeters, and an angle of 36 degrees. X is adjacent to the given angle. To solve for x, we can use trigonometric ratios. The side x is adjacent to the given angle. Hence, we can use the cosine function because we have the adjacent side and the hypotenuse. The cosine function is cos theta equals to adjacent over hypotenuse. Here, the angle is 36 degrees. The adjacent side is x, and the hypotenuse is 7 centimeters. Therefore, we can replace the equation with its units. Our equation is cos times 36 degrees equal to x over 7. Now, we need to multiply both sides by 7 to get rid of the fraction. Hence, the equation is x equals 7 times cos times 36 degrees. If you put it into a calculator, you will get an approximate answer of 5.663. Therefore, the approximate length will be 5.66 centimeters. Don't forget to put the units. Question number 4. Find the length of y to 1 decimal place. In this question, we need to find the missing length. This one's a bit tricky, but the same as the last one, except we have to change the answer to 1 decimal place. Let's work through this. First of all, we need to find a trigonometric function to use. We will use SOHCAHTOA to find it easily. In this triangle, we know that the adjacent side is y and the hypotenuse side is 12 centimeters. So we also know that A and H are two sides we are working with. Then it's part of the CAH from SOHCAHTOA. CAH stands for cosine's ratio to the length of adjacent over hypotenuse. The given angle is 38 degrees, so we need to multiply it by cosine. The units for A and H are y over 12. Next, we need to get rid of the fraction. Multiplying by 12 will do the job. Therefore, we get this equation. Y equals 12 times cosine times 38 degrees. If you put it in a calculator, you should get y equals to approximately 9.45, and so on. If we round that number to the nearest decimal, you will get 9.5. Let's move on to the last one. Question number 5. This one might come off as trickier than the last two. Given a right triangle where one angle is 30 degrees and the hypotenuse is 10 centimeters, find the lengths of the opposite and adjacent sides. To solve this, we need to remember that we are solving for two sides now, the opposite and adjacent. For a 30-degree angle in a right triangle, the side opposite the 30-degree angle is half the hypotenuse. The side adjacent to the 30-degree angle can be found using the Pythagorean theorem or the cosine function. The opposite side equals half times 10, which is 5 centimeters. Now let's work on finding the adjacent side. We can use two functions for this one. Using the cosine function, like we did in the last question to find out the missing side, or the Pythagorean theorem. The Pythagorean theorem will be easier, so let's solve using that. We have the formula, so let's input the values. 5 squared plus b squared equals 10 squared. Calculate the squares. 25 plus b squared equals 100. Isolate b squared by subtracting both sides from 25. Now, you get b squared equals 75. Solve for b by taking the square root of both sides. You will get b equals under root 75. When you put it into a calculator, you will see that the square root of 75 is 8.66. Hence, the answer will be b equals 8.66 centimeters. The triangle will have an opposite side of 5 and an adjacent side of 8.66 centimeters. Now I want you to remember something straightforward, and it's not too hard to remember in all of trigonometry. I discussed this at the start of this video and gave a basic premise. I am talking about the reciprocal trigonometric functions, cosecant, secant, and cotangent. These functions are just as important and are simply the reciprocals of the primary trigonometric functions. You just have to flip the functions upside down simply, and there you go. Remember, the key to mastering trigonometry is practice and familiarizing yourself with these basic functions and formulas. Don't get discouraged if it seems challenging at first. Keep practicing, and soon you'll find it as easy as the title suggests. Thank you all so much for watching this video, and I'll be posting more videos over time. Until then, it's math time.